Okay, so on page 24, so here is your I can statement. I can use deductive reasoning to draw conclusions. So we learned about inductive reasoning. Now we're going to talk about deductive reasoning. So some vocabulary is deductive reasoning, law of detachment, and law of syllogism. So we're going to skip the critique and plan. But here's our essential question. How can you use given and previously known facts to draw conclusions? So, example 1, determine whether a statement is true. So, given that a conditional and its conclusion are true, you can use deductive reasoning to determine whether the hypothesis is true. Deductive reasoning is a process of reasoning using given and previously known facts to draw that logical conclusion. So, you are given the facts that the hypothesis to the conclusion is true and the conclusion itself is true. So when we make the truth table for this condition, we see that we have the hypothesis given the conclusion. If the hypothesis is true, the conclusion is true, then the combo is true. If the hypothesis is true and the conclusion is false, the combination ends up being false. If the hypothesis is false but the conclusion is true, you could still get a true statement. And if the hypothesis is false, the conclusion is false, you could still get a true statement. Okay, so what they're kind of pointing out here is when P given Q and Q are true, P can be true or false. Okay, this is something you're probably going to want to write down in that little blue column right there. Okay. All right. Anybody still writing? All right, so let's talk about our first example on page 24. So determine whether a statement is true. Given that a conditional and its hypothesis are true, can you determine whether the conclusion is true? Why don't you guys take a stab at that? What do you guys think based off of that last slide? The answer's under the meme. No, we're just looking at, the answer's under the meme. I figured rather than having things disappear, I could, So what do you guys think? No, don't worry about the meme. Just worry about what is asking. It says, if the conditional and its hypothesis is true, what can you determine about the conclusion? Would that be true or would that be false? Yeah. It'd be true. Yeah. Okay, so you can conclude that the hypothesis is true given that information. All right, questions on that? Okay, so again, write this in your blue section, the law of detachment. The law of detachment is a law of logic that states if a conditional statement and its hypothesis are true, then its conclusion are true. So here is the actual logic behind it. If P goes to Q, or the hypothesis goes to conclusion, and so basically here's your conditional, and the hypothesis is true, then the conclusion is true. No, Gavin. Is he doing okay? Do you guys know him? Do you guys know him? No. Yeah. So what's like going?
I was with him like
Hmm. Unless he switched and I just don't know about it. No. I just hope he's okay. That's all. Alrighty. Anybody still writing this down? All right. So let's look at an example. So we're going to apply that law of detachment to draw real world and mathematical conclusions. So it says assume that each set of given information is true. All right. If Alyssa scores 85 or greater on her test, she will earn an A as her final grade. Alyssa scores an 89 on her test. What can you logically conclude? What do we think? Alyssa gets a what? An A. Okay. So if you look at the conditional, it says if Alyssa scores 85 or greater on her test, then she will earn an A for her class. The conditional is true. So if we are saying that she scores an 85 or greater on her test, and 89 is in fact greater, so therefore you conclude she gets an A on her test. Okay. If you cannot assume that given information is true, you can use deductive reason to determine whether the conditional and the hypothesis are true. So that's what they're saying here. If this, you're like, maybe that whole 85 or 89 isn't working out, you can use this idea to see if both are true to begin with. Okay, yeah.
are we assuming like the grading system that like 85 isn't?
We're not saying that we're not assuming that about the grading system. We're just saying, hey, if she gets above that 85, she will get an A for the class, because you don't necessarily have to get an A on everything to get an A, right? Does that make sense? Good question. Any other questions? Okay, let's take a look at example B. Again, we're going to assume everything is true. If point D is in the interior of angle ABC, then the measure of ABC equals the measure of ABD plus the measure of DBC. What can you logically conclude about the measure of ABC? First off, this right here. What is that? That's something we've already kind of covered. What do we call that when we're adding two angles together to equal a whole angle? It's a postulate. Angle addition postulate. Very good. So in this case, it says determine the truth value of the conditional and the hypothesis. So here's our conditional. If point D is on the interior of ABC, then the measure of ABC equals the measure of ABD plus the measure of DBC. So there's your conditional. It's the angle addition postulate. So in this case, the hypothesis, point D is on the interior of ABC. That has to be true, right? And if we look at the picture, it's definitely true. So by the law of detachment, the conclusion is true. So you can conclude that the measure of this entire angle is equal to the two individual angles. Okay? Why don't you guys take a minute and do 2A and 2B? All right? For part A, it says if two angles are congruent, then the measures of the two angles are equal to each other. Angle 1 is congruent to angle 2. What can you logically conclude about the measures of angle 1 and angle 2? And then part B, if you finish the race in under 30 minutes, then you win a prize. You finish the race in 26 minutes, what can you conclude? All right. All right, let's talk about letter A. So what can we conclude about letter A? Go ahead. Yeah, the measures of the angles are equal. So in this case, the measure of angle 1 is equal to the measure of angle 2. This little M in front means measure. Since we are getting into proof writing, there is something you do need to know. If you're talking about a measure, you are talking about a physical number, even if you don't know what it is. If you're talking about congruency, it would be just angle 1 would be congruent to angle 2. That's going to be important for tomorrow. There is a difference between a physical measure and the theory of congruency. All right, so just keep that in mind. All right, letter B. What can we conclude about letter B since you ran the race in under 26 minutes? Or in under 30 minutes, I should say. Go ahead. Yeah, you want a prize. Absolutely. So you want a prize. All right, questions on that? All right, let's take a look at the next example. So example 3. All right, so again, you're going to want to write this in the blue section of your companion. The law of syllogism. The law of syllogism is a law of logic that states that given two true conditionals, with the conclusion of the first being the hypothesis of the second, there exists a third true conditional having the hypothesis of the first and the conclusion of the second. So what's happening here is you're given two conditional statements rather than breaking up just one conditional statement. So here it would be our first conditional, where we would have here, this would be our hypothesis and our conclusion. And then that second conditional this would be the conclusion of the first. Okay? That now acts as the hypothesis. So think of it as a little bit like, what property is that? The transitive property, where you have A is equal to B and B is equal to C. So then by definition, A is equal to C, right? So the same idea happens here. You're giving these two conditionals. And since the conclusion of the first is the hypothesis of the second, by definition of the law of syllogism, that hypothesis and that other conclusion end up being true. Show of hands if you are still writing this down. Okay. All right, caught up? Anybody still writing? All right, 10 more seconds. Okay. All right, so let's talk about this. So we're going to apply this law of syllogism to a real world situation. Assume that each set of conclusions is true. What can you conclude using the law of syllogism? If Kenji plays the trumpet, then he plays a brass instrument. So here is our P. Here is our Q. If he plays a brass instrument, he is a member of the marching band. So here now is our Q that kind of transferred over as the hypothesis second. And then he's in the marching band is R. Okay. So the first conditional, if Kenji plays the trumpet, then he plays the brass instrument. Our second conditional, if he plays the brass instrument, then he is a member of the marching band. The conclusion of one statement is the hypothesis of the other. So therefore, we can conclude if Kenji plays the trumpet, then he is a member of the marching band. Okay. Questions on that? Everybody understand where the P's, Q's, and R's are coming from? Okay. All right, so here's our second one. If points A, B, and C are collinear. What does collinear mean? Someone remind me? Good. They land on the same line. Very good. And B is between A and C. So B land, if I drew a picture of this, which is, again, guys, very helpful. Here's A, here's C. B is landing somewhere in the middle. Are they saying B is a midpoint? No. Do you think that's important? Yes. Then hear what they're saying. Then ray BA and ray BC are opposite rays. So here's BA, here's BC. That would be true. If ray BA and BC are opposite rays, so again, there's your Q, then AB plus BC equals AC. So this plus this would equal that. What can you conclude? First conditional, okay? So again, here is our P, here is our Q right here. And then this Q takes over for the second one, and then there's our R. So our first conditional, if points A, B, and C are collinear and B is between A and C, then ray BA and BC are opposite rays. Q to R, if ray BA and BC are opposite rays, then AB plus BC equals AC. So then by the law of syllogism, we would have if points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC would also be true. Now the question is, what postulate is this? Who could tell me? Because it's not listed up here. What's this postulate? AB plus BC equals AC? Segment addition postulate. You think that's going to be important tomorrow? Oh, yeah. Yes, indeedy, it will be.
Do you have like notes on the Google Classroom to study for tomorrow?
You mean on there? We're still kind of vamping it out. I created something this morning during my plan, and the other teacher is checking out to see if she wants to add or subtract anything.
No. What is it called?
Huh?
What are we doing tomorrow?
We're going to start proofreading. Y'all knew this day was coming. Didn't think it would be so soon, but I guarantee. Yeah. You'll find out tomorrow. Huh? What? We didn't go through the whole unit yet. No. This goes to 1-8.
Or no, not Marty's lessons.
8. There's 8 total. Okay. So let's take a look at example 3. It says assume that each set of conditionals is true. Use the law of syllogism to draw a conclusion. I want you guys to try A and B on your own first. Gentlemen, let's get going on these two. Because you have Savas today, but I want to make sure we have enough time to get through everything here. You are also going to have a Google form tonight. Okay. So it'll be kind of reviewing inductive reasoning with you. Yes.
So, wait, do we have a quiz tomorrow?
Why would you have a quiz tomorrow? There's no quiz. We're learning proofwriting tomorrow. We're going to start. Show of hands who's still working on these two. Okay, give you another minute. All right, show of hands if you're still writing these. All right, so if an integer is divisible by 6, it is divisible by 2. If an integer is divisible by 2, then it is an even number. What are we thinking? Someone tell me their answer. Go ahead.
If an integer is divisible by 6, then it's an even number.
Very good. If an integer is divisible by 6, then it is an even number. Nice job. All right, now it says, if it is a holiday, then you do not have to go to school. If it is Labor Day, then it is a holiday. So they kind of did a flip-flop here. What do you think? Very good. If it is Labor Day, then you do not have to go to school. Kind of nice, huh? I think we're way past that though. Labor Day already happened. Yeah.
If you did the inverse of that, would it be wrong?
You're talking about true? Let's see. If you didn't have to go to school, then it would be Labor Day. Well, think about it. Would that be true?
It wouldn't be true.
No, because what about Thanksgiving? What about winter break? What about just institute days? You guys don't have to go to school on those days. You know what I mean?
Yeah, I know what you mean. But like, let's say if we wrote it down like that, like, on just certain, like, right now.
Well, in this case, it would be incorrect. If that's what you're wondering. Yeah, don't write down the inverse. Yeah, good question. Any other questions? All right, let's take a look at 4. All right, so now we're going to apply the law of detachment and syllogism to draw conclusions. So it says, if you are climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level on Earth. So what I'm going to do is I'm going to kind of highlight these statements in different colors. Okay? Not going to talk about hypothesis or conclusions yet. I'm just going to kind of underline them. Okay? So here is one of the conditionals. If you are on the tallest mountain above sea level on Earth, then you are on Mount Everest. Okay, and that says you are climbing a mountain with an altitude of 29,000 feet. So it's giving you 2 conditionals, but then it's tacking on this little comment at the end for that law of detachment. Okay, so the first thing is you need to use the law of detachment because that helps kind of get rid of that one part. All right. So if you are climbing a mountain that has an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level. So we're focusing just sea level on Earth. So you're talking about just this comment in blue, this conditional in blue. But then they're giving you this other part in orange where it says you are climbing a mountain at an altitude of 28,000 feet or higher. So what can we conclude? You are on the tallest mountain above sea level on Earth. Okay. Any questions on that? All right, so that applies the law of detachment. Now we got to apply the law of syllogism. So in this case, it says if you are climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level. And now we're looking at the other conditional statement. If you are on the tallest mountain above sea level on Earth, then you are on Mount Everest. So you can conclude by the law of syllogism that if you are climbing a mountain at an altitude of 28,500 feet or higher, then you are on Mount Everest. So the question is, are you actually on Mount Everest? Yes, because you are climbing something that is 29,000 feet, which is higher than the 28,500. So that would be, by the law of detachment here, you would see that you are, in fact, climbing Mount Everest. Okay? I know this seems odd because we've had some geometry problems, but not a lot. But it's a logic. We're trying to get to that point. Okay? We're just trying to Think of it as like developing your brain a little bit. All right, any questions on this before I move on to the example? All right, check out example 4. Oh, it's not, you guys have Martin, right? I don't know why it did that. Hold on, I had to switch it in the middle because I don't know if it'll. Hold on. There it is. I did change. Okay. I had to change it in the middle of the lesson because it wasn't correct. Why don't you guys work on example 4 while this is loading? There we go. Martin walks his dog before dinner every day. Martin is now eating dinner. Use the law of detachment and syllogism. And what conclusion can you draw from this? All right, so I'm guessing we have a conclusion for this. Someone tell me, what is the conclusion, Evan? Yeah, Martin already walked his dog. If he's eating dinner, he already walked his dog, right? All right, questions on this? All right, I want you guys to turn to page 26, and I want you to do, all right, this is just a conclusion. If you missed writing this down, make sure you have this written down. This is your law of detachment. This is your law of syllogism right here. Okay, last call for that if you don't have it yet. Going once, going twice. Anybody writing? Okay. I want you guys to do 2, 5, 6, 7, and 8. Give those a shot. Bless you. Bless you. What's going on here? All right. How we doing? Is anybody still working on these? You are?
No, can you like explain lawsuits with some attachment easier?
All right. Well, detachment basically has like this extra thing at the end of it. Okay. So it gives you a conditional, if then, but then it gives you saying like something that's happening within the problem. Okay. So, top of my head, I don't know another example, but like with the grade, she needed to get a specific grade, right? And it said she needed to get at least an 85 to get an A for the class. So it said if she gets an 85 or higher on a test, then she will have an A for the class. She got an 89. So therefore, and then it said she got an 89. So it had that little extra part to it, right? Based off that additional piece, you can conclude without a doubt that she got an A in the class. Now, what if it said she got an 80 instead of an 89? Then what could we conclude? She didn't get an A. Does that make sense? So that's the law of detachment. It's a conditional with that extra piece of given information. Syllogism is saying, hey, now we're going to have these two conditional statements. And these guys are going to link using the conclusion of the first as the hypothesis of the second. Okay? So when that happens, you're basically saying that because that conclusion of the first is the hypothesis of the second, then the hypothesis of the first and the conclusion of the second combined also have to be true. Like it links together. It's almost like if you have A equals B and B equals C, then by definition A has to equal C, right? Same idea, but it's involving logic instead. Does that kind of help? You're going to have two conditionals with syllogism. There's no getting around that. So it's going to be a lot more wordy, and it's going to have two if-thens. Does that help? Okay. Any other questions? All right. Let's take a look at this. So let's take a look at the answers here. So it says error analysis. Dakota writes the following as an example of using the law of detachment. What is her error? It says is, if my favorite team wins more than 55 games, they win the championship. My team won the championship, so they won more than 55 games. Her error is that the statement, my team won the championship, is the conclusion. You can't make that a conditional if it's a conclusion in the law of detachment. Okay? So she's going to do it her way. She can't apply detachment. She needs to apply what? Syllogism, because she has the two if-thens. Okay? All right, number 5, if you have a temperature above 100.4 degrees Fahrenheit, then you have a fever. Mario has a temperature of 101.2 degrees Fahrenheit. What can you conclude about Mario? What rule of inference did you use? So what can we conclude about Mario? We have an if-then, and we have this extra little piece of information. So what law is it? Detachment or syllogism? Detachment. So if it's a law of detachment, what can we conclude about Mario? He has a fever. Yep. It says Casey in the book for some reason. But here it says Mario, so we'll just keep it Casey since that's the name of the book, right? Yeah. I'll fix that. All right, 6. If points A, B, and C are collinear with B between A and C, then AB plus BC equals AC. Use the information in the figure shown. What can you conclude about AC? All right, so what they're saying here is you have these collinear points. They are not saying that B is a midpoint. They're just saying, hey, it lands there. If we applied the segment addition postulate here, what can you conclude about this? Go ahead.
8x minus 3 is AC.
Very good. AC equals 8x minus 3. All right. Any questions on 2 through 6 before I move on to 7 and 8? Okay. Assume that each set of conditionals is true. Use the law of syllogism to write the true conditional. So again, you have these two conditionals here. If you eat too much, you get a stomach ache. If you get a stomach ache, you want to rest. So by the law of syllogism, what's this statement going to be? Go ahead. Yeah, if you eat too much, you want to rest. If two numbers are odd, the sum of the numbers is even. If a number is even, then the number is divisible by 2. Ireland, what'd you get for this one? Perfect. If numbers are odd, then the sum is divisible by 2. Easy peasy lemon squeezy, or at least a little better now? How many of you are like, got it? Thumbs up. How many of you are like, I'm starting to get it? How many of you are like, this is not happening right now? We need to talk. Okay. If you are a thumbs down right now, please come see me so I can help you. All right? Everybody else, what I'd like you to do is I am going to post the Google form first. It's 4 questions, and then your homework will be on Savas tonight. Okay? Sure. Those of you watching at home, have a great night.